Hello friends, this is the solution video for question number 28, chapter 6 HC Verma. The problem statement says, find the acceleration of the block of mass m in the situation of the figure shown. The coefficient of friction between the two blocks is mu1 and that between the bigger block and the ground is mu2.
So in this problem, let us try to understand the problem first and then we will try to solve it. Okay. So this is a big block. Let's say this is block A and this is block B. Now try to understand. If this block will move in the right hand direction, so this is the string which is attached through these three pulleys and to this block B, right? Now the major point here to notice that this pulley is attached to this block, right? So once this block is moving in the right hand direction, so this pulley will also move in the right hand direction. So the block B has a different acceleration as compared to block A, because in the case of block B, the string is released twice as compared to as this block A will move in either direction. Okay, so first of all, we should understand that this motion comes under the constraint motion, because in this case the pulley is also moving, right? To find the relation between acceleration of B versus acceleration of A, so the one way is using the distance method and the other way is using the constraint motion concept. Okay, so I will use the constraint motion concept here, because if you understand that concept, you can use that concept in any tough scenarios. So for that, let's say the acceleration of block A is A and the acceleration of B is A dash. So I am considering this block A is moving in the right hand direction. So obviously this block B will move in the downward direction. Okay. The tension is, say, T in the string. Since this string is same, so tension is everywhere remain same. So what does constraint motion says? Constraint motion says summation of T, which is tension, dot A, which is acceleration, is always 0. So if you want to understand this concept, you can watch my video given in this link. Okay. Now, first of all, we will see what is the angle between tension and acceleration at different points. Now, for the block B, tension and acceleration has opposite direction. Okay, so in that case, I would say tension into A dash cos of 180 degree, right? Because we know that T dot A is TA cos theta. Now, for this tension T and A has same direction. That means it is going to be TA cos of 0 degree. Now again, this tension and acceleration again has same direction. So that means it is going to be TA cos of 0 degree is equal to 0. Now what is cos 180 degree? It will give you -1. So minus TA dash plus TA plus TA, because cos 0 is 1, right, is equal to 0. So this will give you 2TA is equal to TA dash, T will cancel out, so this will become A dash is equal to twice of A. So that means acceleration of block B is twice as acceleration of block A. The other way is using the distance method, where we can say, when this block is moving in the right hand direction, so let's say the X length of string is released. So same length will be released from the upper part, and this X plus X will be added up in the block B string, right? So to cover the 2x distance in the same time, the block B has to accelerate twice as compared to A. So for in this scenario, this understanding is fine, but this is a mathematical way to find the relation between two bodies in constraint motion. So this one is the best method where you can use in any scenarios. Now if we found the relation between A dash and A, so which is A dash is equal to 2A, right? Now we analyze the free body diagrams of individual block and we will try to solve this problem. Okay, so first of all, I am drawing the FBD of B. So let's say this is the block. The tension T is in upward direction. The mass mg will be acting downward direction, right? Now there will be a frictional force between block B and block A. So now block B is moving in the downward direction. So the frictional force will act in the upward direction. So I am saying it is as F1. Okay. The acceleration is A dash in the downward direction. Now this B will also move under the influence of block A. So when block will move in the right hand direction, so B will also move in the right hand direction. Okay. So now the block A is moving with an acceleration of A. So that means there will be a pseudo force which will act on block B in the left hand direction, which is given as MA. Okay. Now there will be a contact force which is equal and opposite to this MA, and that is nothing but the reaction force. So let's say that is R1, right? Now for the vertical forces, we can say that mg minus T minus F1 is equal to MA dash. Also for the horizontal forces, we can say that R1 is equal to MA, or now we can say that the frictional force F1 is mu1 R1. The value of R1 is MA, that means mu1 into M into A, right? So now in this equation, minus T is equal to MA dash plus F1 minus mg. Adjusting the sign, T is equal to mg minus MA dash minus of F1. Value of F1 is mu1 MA. Now putting the value of F1 mu1 MA. Okay. So this is the value of T. Now we'll draw FBD of A. So this is the bigger block, which is A. A pulley is also attached to it. So I am drawing this pulley as separate one to understand this scenario. Okay. The acceleration A is in right hand direction. There is a tension T in the string. The frictional force will act in the backward direction. Let's say that is F2. The frictional force F1 in this case will act in the downward direction. The mg force will act downward direction, and there will be a reaction force which is say R2. Now there is a tension T which will try to pull this block in the right hand direction. So this tension is also applied on this block because this pulley is attached to this block, right? Again, this pulley will also try to pull it down with a tension T, right? Also, the reaction force R1 now will act in the backward direction for block A, right? So this is R1. Now from FBD of A, the vertical forces are R2 is equal to mg plus F1 plus T, right? Now putting the value of F1 as mu1 MA, so this R2 will become mg plus mu1 MA plus, we will put the value of T from this equation, and also in this equation A dash can be converted into A. So we can say that T is equal to mg minus A dash is 2A. So I am putting the value of A dash here. So this will become 2MA minus mu1 MA. Let's say this is equation 1. Now putting the value of T from equation 1 into this one. So it will become mg minus 2MA minus mu1 MA. So this mu1 MA will cancel out. So this R2 will become mg plus mg minus 2MA. Let's say this is equation number 2. Fine. For the horizontal forces now, so this is going to be 2T, T plus T minus R1. R1 is in backward direction, minus F2, F2 is in backward direction is equal to MA. Now we know that F2 is equal to mu2 into R2. The value of R2 can be fed from here, right? So this will become mu2 times mg plus mg minus 2ma. Okay, now put in the value of F2, R1 and T from equation 1. So it will become twice of mg minus 2ma minus mu1 ma minus R1 is ma minus F2 is mu2 times mg plus mg minus 2ma is equal to m into a. Now further solving this will become 2mg minus 4ma minus 2 mu1 ma minus ma minus mu2 mg minus mu2 mg minus minus plus 2 mu2 ma is equal to m into a. Now taking all the a part in the right hand direction and rest in the left hand direction, so this will become 2mg minus mu2 mg minus mu2 mg is equal to ma minus 4ma minus 4ma minus 4ma is 5ma, so 5ma plus 2 mu1 ma minus 2 mu2 ma. Okay, now taking a common in the right hand direction and g common in the left hand direction, so a will become 2m minus mu2 m plus m times g upon m plus m times 5 plus 2 mu1 minus mu2, right? So this is the solution of this problem.